Welcome back, everyone. And this course is going to be, or this lecture is going to be about classes of IP addresses. But before we start, I want to clarify something that I've ran into in other videos that I've done. There's a difference when I talk about classes of IPs. We're doing IP version 4. Yes, with IP version 6, there are no classes anymore, okay? But with IP version 4, there are classes of IP addresses. You must know how to identify what class of IP address. Because depending on the class of IP address that you have in IP version 4, okay, you can have either 254 hosts, or you can have 65,000 plus hosts, or 16 million hosts, all depending on the class of IP address that you have. Because if you go beyond those boundaries, then you're really supernetting. You're not just using the default mask what they use. So, because I know a lot of people get confused because when I say class of IP address, they're thinking classless routing, which is using VLSM. We're not talking about classless routing. We're talking about identifying the IP address. What class does it belong to? So keep that in mind, because again, certification, certification, certification. All right, this is what you're going to be looking at. A+, Network Plus, CCNA. And if you go out there, some people, you see them using a 10.1. something, or a 192, or a 172, and there's a reason for that. Because if you work, again, your books will tell you, if you work for a small corporation, you may want to use the 192, and you'll see in a second why. If you're using for a medium size, you may want to use the 172. And if you're going higher than that, you're using for government agencies, then 10. Why am I using those specifics? You'll learn in a second. All right, so let's get started with this lesson. So classes of IP addresses. Well, we have different classes. We have class A, class B, class C, D, and E. Now this also causes some controversy. Class A, there's a range. And when we're talking about ranges, we're talking about the very first octet. I'm going to put it out here. So when we talk about classes and identifying an IP address, what class it is, we're focusing only on the first octet. So when I write the range, is the range in the first octet. So the range for a class A is 1 through 126. Hey Laz, what happened to the 0? Remember in the previous lecture that 0.0.0.0 is the gateway of last resort? It is a reserved address. So therefore, you cannot use it. Therefore, it's not in the range. The true range is 1 through 126, okay, for a class A. How about a class B? 128 to 191. Again, why didn't we put 127 here? Again, previous lecture. Because 127 is your loopback address. So you cannot use it. So therefore, it's not part of a range. That's why it's not there. Certain books will explain that's from 0 to 127, but you have to take away the 0 and the 127 because it's not in the range because they're invalid addresses to assign to nodes, right? Any device on the network. So therefore, they're not part of the range. So the true range for an A is 1 through 126. For a B, 128 to 191. For a C, 192 to 223. For a D, 224 to 239. If you watched the previous lecture, you should know what this one is already, right? This is your multicast address right there. And E, 240 to 255. There you go. That's the last one, right? So, because the maximum value, right? What's the maximum value of any octet? The maximum value of any octet is 255. Can't go beyond that. If you ever see an address that has a 256, immediately invalid, no good. Don't even do anything else. That's the problem right there, 256. Okay? All right. So these are the range. So if you see a number here, that's, like I said, remember earlier, 172? Well, 172, where does it fall? It falls in here. So this must be a class B address. If you see a 10, like I said earlier, hey, that falls in here. So that must be a Class A address. And if you see a 192, hey, that's a Class C address. Now, you already know that these were multicast addresses. We spoke about it earlier. We use that your routing protocols such as RIP version 2, EIGRP, and OSPF use in order to send out their updates, right? Or if we're going to do video conferencing and what have you. But we never talked about this range. And you know why? Because in every book that I've ever seen, this is all they say, experimental. That's it. You're not allowed to use it. Maybe Black Ops, CIA, who knows? The scientists that are behind closed doors only use that. I have no idea. So what I do know is that you can't assign it. Your nose will scream at you if you try. And we just don't use it. You're not being tested on it. But at least know them. Know them. Because if they give you a written test, they may just decide to give you, hey, this computer's assigned to the 240.1.100.80, right? And you're like, oh, why doesn't it work? Well, first of all, it's a 240. It's an experimental address. You can't use it. There's no math. There's nothing else to even think about. So a lot of these questions, believe it or not, just by being able to identify the address, you're like, aha, that's the problem. Okay? All right. So these are your class of addresses. Now, they all have a default mask for a class A, and really, we can get rid of these two because you're not, going to be working with these in any kind of, in any configurations whatsoever. So for a class A, you have a 255.0.0.0. For a class B, you have a 255.255.0.0. And for a class C, you have a 255.0. And this is why this is so important to know the class of address. Because if you have a class A address, right here is telling you that this side right here is completely on. You cannot mess with it. You cannot use it. So for host, you have all these available to you. Right there. You have 16,777,214 addresses that are available to you for you to use. So again, if you work for a huge company, right, that has hundreds and thousands, millions of nodes spread out everywhere, hey, look what you can do. All right? You can use that. With a B, there you go. These two will always be the same. You cannot go beyond this boundary for right now. You cannot go to this boundary. You have all these two octets to mess with for host addresses. How many host addresses do you have? 65,534. I know some of you are saying, hey, isn't it 16? I already subtracted 2. Isn't it 36? I already subtracted 2. Okay? The two addresses. And what are the two addresses you don't use? Your network ID and your broadcast address. Okay? So look at that. Medium-sized company, right? 65,000 addresses. That's why I use a B. And a C, hey, right here, this is your boundary, buddy. You can't go beyond that. So what do you have for host? Just this octet right here. For host, how many do you have? 254 hosts. That's it. In my network consulting that I've gone to several companies, they shot themselves in the foot because they started using Class C because they weren't that big to begin with, but they did not expect how quickly they grew. They were very successful, but they were using a Class C address. They exhausted the Class C address range. So now what? What do? Do they go to another class and start routing between? Do they redo their scheme? What do they do? So it was a very interesting job, all right, to help them out with this. Okay, but again, when you're trying to do your scheme, think of what is this company doing? How big are they? What is going to be their growth to allow for growth for your IP scheme? One of the reasons that we're switching over to IPv6 and why IPv4 was exhausted and there's so many problems with it because we never thought that the public addresses, and again goes public, private, there's a difference, because of the public addresses started being wasted quickly. They knew that the World Wide Web was going to explode so quickly, so the backbone routers are suffering. There was no hierarchy. They're doing so much routing. The routing tables are so huge because we just started throwing addresses out there however which way. And then we ran into issues. Designing, planning your infrastructure, your IP infrastructure especially, is extremely important, because you may start with this because you think your company's not going to grow, and then you run out of IP or the Class C addressing. Now what? Now you got to go somewhere else, or you have to redesign. Okay? So keep that in mind. This is classes of IP addresses. This is why we use this. Okay? And we need to understand. So again, these are the classes, A, B, C, D, and E. Don't forget D and E, which is D is your multicast, E is your experimental. The ranges, this is based on the first octet. Okay? And their default subnet mask for an A, B, or C, and the amount of default hosts you can have with each class of address. Now, let's not get this confused. The class of address, let me rephrase that. The subnet mask doesn't determine the class of address, because you see this subnet mask here, correct? And you see the ranges. So let me give you a little example where people also get confused. You have a Class A address. Let's use the normal ones we all work with, 10.1.1.0. Now, and we have then, let's say, a Class C address, 192.168.1.0. Now, by default, a Class A has a 255.0.0.0. And by default, a Class C address has 255.255.255.0. But we don't do that, do we? We don't use the default mask. What do? We go 255.255.255.0. Our original line is here by default. Well, we decided that we're not going to do that. We want it here. We want that to be the network and just allow so many because we subnet it. So just because we changed the mask, now this becomes a Class C address? No, it does not. This is a Class A address that has been subnetted by using this mask. What about this guy right here? If we were to go like this now, the default line is right here, correct? But what if we decide to do this? Does that mean that this one becomes, because it has a 255.255.0.0, the default for a B, that this automatically, magically turned into a B? No, it did not. It's still a C, but now you move the line over here. So here, we moved it like this. Here, we moved it like this. Well, here we subnet it. Here we supernet it. You see? You really can't take it back this way unless you are supernetting. You're pretty much stuck over here in the slider 24. All right? But what I'm trying to explain here is that the subnet mask does not determine the class of address. Do not get that confused. Okay? Do not get that confused. You can use whatever mask based on the requirements of your network. Okay? But again, you have default lines and default masks. Okay? All right. Now, those are your classes of all the ranges. But now we have private IP addressing schemes. Private. What does it mean to be private? What is a private IP address? A private IP address is an IP address that cannot be routed onto the internet, to the public side. Unless you do what? Unless you have the NAT routing protocol configured. to do their translation for you. All right? And that's what you will always see instructors, professors, whoever, use these as examples because we're used to seeing this. When they start putting actual public addresses, it gets kind of confusing. But just remember the range. All right, but now we have a private range. We have a private range. And I think I may show you something that you guys never seen before. So listen carefully. This is very interesting. All right, so let's look at the private range. What I'm going to show you now is the private IP version 4, remember it's all version 4, range. For the class A is 10.0.0.1 through 10.0.0.255. So the entire range of class A, 255, 255, 255. Oh, 254. There you go. Sorry about that. So the entire class A range, anything you see with a 10 at the beginning, that's a private IP address. It cannot be routed onto the internet. Cannot. Unless you have NAT, okay, to do the translation to a public IP. Only public IPs can sit on the actual interface and be able to go out to the internet. Only public. Private IP addresses in a class A like this cannot go onto the internet without using NAT. So those of you that buy Linksys routers or D-Link routers, all right, NAT's already configured on there. You don't even have to mess with it. It's already in there. That's why you can automatically just plug it in and go out. Because you have a public side, which is your provider, and the private side, which is your Linksys that is assigning addresses to your local network. Okay? So this is the class A. Class B, and of course, the default mask of 255.0.0.0. Okay? Now, class B, 172.31, no, got ahead of myself, .16.0.1 through 172.31.255.254. Now, in most books, networking books, you're going to see the default mask. And if you were to go into the TCP/IP properties and actually put in 172, it's going to know, hey, and you hit tab, you put in your IP address, you hit tab, it's going to populate it with 255.255.0.0. But a question was proposed to me one time as to, hey, Laz, why these two? I cannot answer that question. I don't know why they chose those two, but I know how they chose those two, and it's not using that mask. Let me prove it to you. 172 you can't use. That's completely being taken up. But in this octet, it's partially on. 1, 2, 3, 4. 1, 2, 3, 4. And these two octets off. Okay? Your imaginary line and our focus is on this second octet. Remember your bit values. Let me change color here. Remember your bit values. 1, 2, 4, 8, 16. Okay? So, 172, first octet, 16, 0, 0. Why 0, 0? This is your network ID. Now, these also have bit values here. I'm going to add these guys. And you're going to learn this later on. So don't worry if I'm going a little fast here. You're going to learn how to do this. You're going to learn how to do this in your sleep. Second octet. 15 and 16. Third octet. 255 and 0. Fourth octet. There's your range, right? Your range is 16, 0, 1 through 31, 255, 254. There's your range. So what is the true mask? 255, I'll just put it on here, 255, 240.0.0. Look at that. Why is it 240? Bit to decimal table. 1, 2, 3, 4. If you guys didn't see the free hex video, that's why I explained that. Well, I'll explain it here as well. 1, 2, 3, 4. You add these 4-bit values. That's how you get your mask. So really, in a private range, since we're limited to 16 to 31, it's really 255, 240. That's how I came up with those two figures right there in the second octet. Because if you see 172.15, it's a public address. If you see 172.32, it's a public address. But if you see 172.16 or 172.31, it's a private IP address. And this is how they do it, by using this mask. Okay? Just wanted to give you that pointer if you've never seen that before. Okay? Class C, 192.168, 0.1 through 192.168.255.254. So now, again, if you go to the TCP IP properties and you hit tab, it's going to give you the default of a Class C. But what numbers here don't change? There's two numbers that stay the same, right? These two. They don't change. So they allow you to change the third octet. So really, your little magical line is right here. So really, they're allowing you to do that. 16. I didn't make this up. If you've ever taken the Cisco Academy course, all right, and you go through the whole thing, all right, that's how they teach you. Okay, that's how they teach you. Well, that's how I used to teach as well. All right, because I have taught the Cisco Academy courses. All right, and this is one of the things that pretty much it confuses people. All right, when you first look at it, you're like, wait a minute, I've never seen that before. Because really only they're the ones that kind of keep it to themselves, I guess. Everybody, and again, when I first started teaching, this is how I thought. I'm like, well, 1631, you know what? It is what it is. Just memorize it. That's all you need to know. And the Class B is a Saturn 16, and this is my range, and that's it. But just to give you a better understanding how they came up with these numbers and the real mass, which was 255, 240, to get this particular range. All right? And the Class C, the same. Just try to look at it. Hey, these two octets don't change, but this one does. So really, they're allowing you to come all the way up to here. Okay? But we use 254 here. Because if you really use a private, even if it's private, if you use anything using a Class C address that's less than 24, now we're supernetting. Okay? Just so you know how many IP addresses you can have though, truly in a private range. You can have up to 65,000 also, but in different networks using a SATA 24. I know it sounds confusing. As we go along through the course, things will start making more sense because I know you've never maybe heard this before. All right, but when we start doing the labs and when we start getting more into the subnetting, you'll understand. All right, so again, these are your classes of addresses. You have your A, B, C, D, and E. You have your ranges, A, which is 1 through 126, B, 172. Oh, I'm sorry, B is 128 to 191. C is from 192 to 223, D 224 to 239, E 240 to 255, and you need to know it like that. All right, your default mask 255.0.0.0 and so forth. So you know your mask, your default host. Should you remember it? You know, you should. Some certification, you may be the only guy or gal that takes the certification and they ask you that silly question. How many hosts are in a Class A address using the default mask? And you have 16,777,200 and it's really 214. They'll play some game like that and you want to answer it right. So there's some things we just need to commit to memory. At least the default settings or default configuration, commit them to memory, and then we can figure everything out later on, okay? And then you have your private range, which a private IP address is not routable on the internet at all unless you're using NAT, right? And then there's your private range right here and the default mask. Now, even though I showed you 255.240, don't you ever on an exam, because they don't expect people to know 255.240 or 255.255. In an exam, you will always, if it's a Class B, 255, 255. If it's a Class C, 255, 255, 255. If it's a Class A, 255. Keep it to what we know, but I'm just showing you this so you have a better understanding how these numbers get they came up with. All right? All right, that's this lecture. If you have to watch this video this lecture a million times, go ahead and do so. All right? But as we continue throughout the course, you'll start getting a better understanding of everything. All right, hope to see you soon.